वेलकम। आज की इस वीडियो में हम हमारे समाकलन गणित की सीरीज को आगे बढ़ाते हुए देखने वाले हैं लीजेंडर्स डुप्लीकेशन फॉर्मूला। पिछली वीडियोस में हम बीटा गामा फंक्शन की कई सारी प्रॉपर्टीज देख चुके हैं। ठीक है, तो आज हम देखने वाले लीजेंडर्स डुप्लीकेशन फॉर्मूला। सबसे पहले देखते हैं लीजेंडर्स डुप्लीकेशन फॉर्मूला होता क्या है, उसके बाद हम इसे प्रूव करेंगे। ठीक है, तो ये होता है गामा एम इंटू गामा एम प्लस 1/2 इक्वल होता है रूट पाई अपॉन 2 to the power 2m minus 1 into gamma 2m where m belongs to integers. So this is our Legendre's duplication formula. इसको हम बीटा गामा फंक्शन के बीच में जो रिलेशन होता है उसमें मदद से प्रूव करते हैं। तो सबसे पहले देखते हैं बीटा गामा फंक्शन का रिलेशन होता क्या है। ओके, तो बीटा एम एन इक्वल गामा एम इंटू गामा एन अपन गामा एम प्लस एन। सो इस रिलेशन की मदद से हम जो है इस लीजेंडर्स डुप्लीकेशन फॉर्मूला को प्रूव करने वाले हैं। इसका प्रूफ हम देख चुके हैं वीडियो में। ठीक है, तो सबसे पहले हम सपोज दिस इक्वेशन 1। हां, तो लेट n equal 1/2 in equation first. Okay, so what we will get beta m comma 1/2 will be gamma m into gamma 1/2 upon gamma m plus 1/2. Okay, and we will use here the property of gamma function. That is, we can write the gamma function as integration 0 to pi by 2. Right, so and what is this value? We will get sin to the power 2m minus 1 theta, 2m minus 1 theta into cos to the power 2m minus 1 theta. And what is n? 1/2 minus 1 theta dot d theta. Here m into gamma 1/2 upon gamma m plus 1/2. Now we will further solve it, so we will get twice of 0 to pi by 2 sin to the power 2m minus 1 theta dot this will be 1 minus 0. This will be 1. Okay, so d theta. Now gamma n, and what is the value of gamma 1/2? That is 2 pi. We have also proved this property in recent videos, so you can see the proof at 1/2. Okay, so what we can say that the value of 0 to pi by 2 sin to the power 2m minus 1 theta dot d theta will be equal to gamma n into root pi upon 2 into gamma m plus 1/2. So this is our equation second. Okay, now we will put the value of m equal n. Okay, or we can say the value of n equal m in equation first. Okay, now we will put the value of n as m. That is, we will solve both the m and n as the m. Okay, so let's beta mn will be 0 to, sorry, here we will use the property in the next step. So what is the function of gamma function? Okay, so we can write gamma m into gamma m because m is also n. The value of n is also m here. Okay, I hope you understand. We have simply put the value of n as m. So here n will be m and gamma m plus n. Okay, and what is the value of n? We have put ms. So we can write it as the value of square upon here what we get 2m. Okay, now we'll move ahead. So now we'll use the property of beta function here again. So twice of 0 to pi by 2 integration sin to the power 2m minus 1 theta cos to the power 2m minus 1 theta because n is also m here. Okay, so this was m, not n. I hope you understand. Now d theta will be equal to square upon gamma 2m. Okay, so now what we can write here as 0 to pi by 2 sin to the power 2m minus 1 theta cos to the power 2m minus 1 theta d theta will be equal to whole square of gamma n upon gamma 2m. Okay, now we will use the property of sin theta. So if I write, suppose this is sin theta into cos theta. Okay, so let's put the power common. So I can write sin theta dot cos theta to the power 2m minus 1 theta, 2m minus 1. Okay, 2m theta and d theta, because we can because the power is same, so we can take the power common. And here whole square of gamma n and 2 gamma n to gamma 2m. Now we will further simplify this. So if I put 2 sin theta cos theta, that will be sin 2 theta. Okay, so I will multiply this 2. Okay, and also I have to divide with 2. So to the power 2m minus 1. Here we will get 2 sin theta cos theta d theta, and the power is 2m minus 1. Here the square of gamma n upon gamma 2m. Okay, so what I can write 1 upon 2 to the power 2m minus 1 will be equal to sin 2 theta dot d theta, and here the sign of integration. Okay, now 0 to pi by 2, and here the same value gamma 2m. Okay, so we have followed something that was 2 na, this 2 is missing, so this was a numerator 2 and 1 into 2 the cos, and this is 2. Now okay, so now we will further solve. So 2 to the power 2m minus 1 equal, now we will solve this function. Let's suppose here 2 theta as t, and what can we write? D theta will be t by dt by d theta will be dt by 2. Okay, and limit will be 0 to pi, as you can see. When theta is 0, t is 0. Okay, but when theta is pi by 2, then t will be pi. Okay, so here I can write 2 to the power 2m minus 1 into 0 to pi sin, and also the power is 2m minus 1, and here sin t to the power 2m minus 1 dot dt by 2, and here same square upon gamma 2m. Okay, so what we can write here, I can write this 2 out of this integration, so this 2 we cancel out this 2, so 1 upon 2 to the power 2m minus 1, and this will be 0 to not pi by 2, this is limit has been changed, so this is only pi. Okay, so 0 to pi sin 2m minus 1 t dt will be equal to gamma 1 whole square and gamma 2m. Okay, so I hope you understand here what we have done. Now we will further solve this equation. Now we will use the property of integration. So suppose this is 2 to the power 2m minus 1. Now we will break this limit into two intervals. Okay, so if I because this is a symmetric function, so the value of 0 to pi by 2 will be equal to pi by 2 to pi. Okay, I hope you know the basic values of integration. So if I write twice of 0 to pi by 2, and the function will be same, so 2m minus 1 t dot dt, then this will be the same value of this, because we have break the limit into two intervals. Okay, sorry, this is integration. Now here we have the same value gamma m whole square gamma 2m. Now okay, so we can say that the value of 0 to pi by 2 sine to the power 2m minus 1. Now the we can change this t as theta because the variable is same and dt. Okay, so if we put t equal theta, there will be no change in neither in the function nor in the limit, because if we put t equal 0, then theta will be 0, and if we put t equal pi by 2, theta will also be pi by 2. Okay, so this is also a basic property of integration. You can change the variable all along. Okay, if it does not change the limit. Okay, so theta dot d theta and pi upon 2 gamma 2m. Now suppose this is our equation third. Okay, so what was our equation second? Our equation second was this was our equation second. Okay, so see carefully, we have got the same term in the equation third, so we will put these both equation as equal. So we will get here gamma m into root pi upon 2 gamma m plus 1 by 2. Okay, so I can say that the value of, okay, you see the value in left side both are same, so I can write the value of from equations second and third. What we can say, we can write that the value of gamma m into root pi upon the value of what we got here, 2 gamma m plus 1 by 2. 2 gamma m plus 1 by 2 will be equal to here gamma m whole square and 2 gamma 2m. Now we will solve this. So this will be cancelled out with 1 and 2 will be cancelled out from 2. Now we have mistaken something. We have forgot this term. Okay, so this will be here. Okay, let me write this term into, we have to do this term, so 2 to the power 2m minus 1. Okay, so 2 to the power 2m minus 1 here. Now what we get, root pi upon gamma m plus 1 by 2 equal gamma m upon gamma 2m 2 to the power 2m minus 1. Now we have got the required Legendre's duplication formula. We will arrange this in the same manner as we have told earlier. So now what we have seen, we will see that gamma m here and we will multiply here. So gamma m plus 1 by 2, what we will get, root pi into gamma 2m upon here 2 to the power 2m minus 1. Okay, so let's further rewrite it. So gamma m into gamma m plus 1 by 2 will be equal to root pi upon 2 to the power 2m minus 1 into gamma 2m, and this was our required Legendre's duplication formula. Okay, we have forgot something, the m, gamma m. Okay, here gamma m also remaining, so gamma m, this is gamma m, and this was our required Legendre's duplication formula. Okay, so now we will meet in the next video with some other properties of beta and gamma function. After that we will solve some questions. Okay, until then, thank you.